Hey guys, thought I'd toss together a quick little video to help anybody out finish up the lab in case they didn't get things done in class today. Today we were building candy models and trying to model the difference between an ionic and a covalent bond. And the big idea we were trying to get across is that in covalent bonds, we're going to share electrons, and those ionic bonds, electrons going to transfer, and we're not actually going to see a physical bond holding them together. For the class today, we used gumdrops. We used the yellow gumdrops for hydrogen, some purple gumdrops for carbon, orange ones for nitrogen, green for chlorine, and red for oxygen. We used nerds to represent electrons today. We used white marshmallows to represent our only metal of the day, sodium, and then we used toothpicks to represent covalent bonds. To start off class, we did two examples together in class. We did these two in which we modeled N2. We saw that that was a non-metal bond. It was a covalent bond because it's non-metal, and in all covalent bonds, the electrons are going to be shared. And then we built our object in which we had our orange gumdrop representing nitrogen, our second orange gumdrop representing the second nitrogen, since it's N2, and then our three covalent bonds. And we drew up on the board on how we could come up with those covalent bonds in class today. Here I've actually given you some other answers for the first page so that you could check and see if you're doing the things the right way. And so again in class we did the Na3N. Here, since it has a sodium in it, sodium being a marshmallow, is a metal. It's our only metal of the day. And so since it's a metal and a non-metal, we're not going to see a covalent bond. We see an ionic bond. And in ionic bonds, the electrons are transferred. In this case, the electrons are going to leave sodium and go to nitrogen. And so we modeled it over here by having three marshmallows, those representing our sodiums. And then the showing of the electron transferring, we would stick three electrons into nitrogen to show that those electrons left our marshmallows, went over to our nitrogen. And so we ended up with some orange gumdrops with the nerds stuck into them. Here I've given you guys a bit more information. These are the ones you're starting to work out on your own. These are the Lewis dot diagrams for hydrogen and oxygen down here that we're working with. You can see here oxygen has 6 valence electrons. Hydrogen each have 1. We're looking for those electrons here on the top of our oxygen and the bottom hydrogen that are not paired. That's going to become where our bond is made, and over here on the side we're going to see a bond form over there with this unpaired electron there. And so we end up with a water molecule here. Since hydrogen's a nonmetal and oxygen's a nonmetal, that's going to be a covalent bond. Electrons will be shared. And then we made it using our gumdrops here. So that's a picture of one that I made in class today. For the O2, same idea. We're going to look here. We see that oxygen has still 6 valence electrons, and we have 2 of them now. The first thing you're going to do is make one bond between them, and you'll see that you would have 1, 2, 3, 4. Your bond would count as 2, so 5, 6, and then the 1 electron at the top would count as 7. You haven't gotten to the 8 that you need, and so to make oxygen work, you're going to need to share 2 electrons across, and so that's going to give you a double bond. So your model should look like this, where you have the 2 red gumdrops representing each of the oxygens, and then 2 popsicle sticks for the bond, toothpicks for your bonds. And I'll give you one more here as some help. This is one of the ionic bonds that you guys had to do in class, and we know it's an ionic bond because it has a metal in it, and it's the same metal we've seen in the other parts of the lab, which is sodium. So every time you saw sodium today, that's going to be an ionic bond because that's going to be a metal. Again, we're not going to draw the toothpicks or the lines in between because the electrons are transferred, and so sodium gives up its electron over to chlorine, makes a negative chlorine ion, makes a positive sodium ion. And the way that we showed that in class is we would have our marshmallow representing our positive sodium ion, and then we stuck an electron onto a green one representing chlorine, showing the electron is now over there. All right, guys. Let's zip down to the bottom here. On your paragraph that you guys had to write, just like in language arts class, we're looking for that opening sentence to be a claim, 3 supporting details, and then a conclusion. This one's fairly straightforward today. A nice, easy way to start your claim is, we're looking at, is there a difference between ionic and covalent bonds? And you could say covalent and ionic bonds are different. It can be a very simple claim for today. And then I'm looking for 3 supporting details telling me how covalent and ionic bonds are different, and then a conclusion or a closing for that. So good luck on today's lab. Good job in class. Most people did a lot of hard work to try and get this lab done in a day, and I really appreciate that. Okay, guys, see you tomorrow. Take care.